Hi, welcome again. This is subsection 3.1 in which we are going to study about corrosion and rancidity. This is one of the most interesting topic of this chapter. So you're gonna have a lot of fun here. Okay, now tell me one thing. Have you ever seen that in Uncle Chips packets and in Lay's packets, you find most of the portion is filled with gas, whereas the quantity of chips is very low, right? And also, have you seen when the food is kept in the room temperature for a longer period of time, then an unpleasant smell starts coming from that food, right? Also, have you ever seen black coating on silver coins, green coating on statues made up of copper, and also orange rust on iron substances? Now, do you know the reasons of those wonders? Today, you are going to find answers to all those questions. So today we are going to study about corrosion, which is eating up of metal by the action of its surrounding environment, and rancidity, which is aerial oxidation of fats and oils present in the food. We are going to take them one by one. So let's start with that. Now, corrosion and rancidity. These are the effects of aerial oxidation. Now you must be wondering, what is aerial oxidation? Now again, what is the meaning of aerial? Aerial means related to air and oxidation means oxidizing the element. Okay, so aerial oxidation means oxidation caused by oxygen present in the air. Now, this aerial oxidation have damaging effects on metals and food. So, we can say damaging effects of oxidation on metal is called corrosion, and damaging effect of oxidation on food is rancidity, right? Now, the most simple definition of corrosion is aerial oxidation of metal, and the most simple definition of rancidity is aerial oxidation of fats and oils present in the food. So by now you must be knowing what is aerial oxidation. It is just oxidation caused by oxygen present in air. Now what happens is, this corrosion breaks the metal and make it very weak and ugly. That is why our government actually spend millions every year in order to prevent corrosion. Now, one thing I want to tell you, most of the students confuse corrosion with rusting. They feel that these two terms are all same. Actually, rusting is a part of corrosion. Corrosion of iron is called rusting. Now with the help of the equation, I will be telling you about rusting, and also that rusting is a redox reaction. Now let us understand one of the most common example of corrosion, which is rusting. So basically corrosion of iron is called as rusting. Now suppose you have pure iron here, okay, and then it reacts with the oxygen present in the air along with the water molecules. So there can be any number of water molecules, so that is why I am writing X here. Okay, now what happens is, this iron get oxidized and form Fe2O3 dot XH2O. Okay, now this is the formula for rust, which is orange in color. Now what is happening here? Basically iron is getting oxidized, and that is why you can see it is Fe2O3, and that is why we can write here oxidation. Now if I am writing oxidation here, then I can put reducing agent here, right? I told you, you need to write opposite of it. Now talking about oxygen, so this oxygen is basically a non-metal and it is combining with iron, and this iron is a metal. So a non-metal is combining with a metal. You know about this mnemonic RAM. So what does it says? Reduction is addition of a metal to a non-metal. So to a non-metal, a metal is added, and that is why we can say that it is a reduction process. So if I am writing reduction here, then I have to write oxidizing agent. So if you can see here, reduction and oxidation both are occurring simultaneously, and that is why we can say that rusting of iron is a redox reaction. So this is one of the most important questions that can come up from this topic. Now next, the question arises, why this corrosion happen? Now let me tell you, most of the metals undergoes corrosion because metal actually occur in combined form. Okay, so after providing the energy, the combined form of metal is refined and the pure metal is extracted from it. Okay, now this pure metal is not so stable. So what happens is, start combining with the gases present in the environment, and when they react with them, we say that the metal is getting corroded. So actually the corroded metal is much more stable than the pure metal, and that is why we say that metal tends to corrode. Now the next thing is, how can we prevent the corrosion? Okay, so this is something which we are going to understand in depth in unit number 3, in which we are going to talk about metals and non-metals. As of now I am telling you in brief. Okay, so what happens is, you can actually paint the objects in order to prevent the corrosion. So basically what happens is, when a coat of paint is applied to the surface of an iron object, then air and moisture cannot come in contact with the pure iron metal and rusting is prevented. Next is greasing. Okay, so oiling and greasing is another way, with the help of which you can prevent the air and moisture to come in contact with the iron object. Next is galvanization. So what is galvanization? It means to coat the iron object with the zinc metal. Okay, so zinc is actually more reactive than iron. If you remember this, ka na ka meg al zan fi. So iron is below and zinc is above it. So zinc is more reactive than iron. That is why zinc, when kept in air, actually reacts with oxygen present in the air and forms a layer of zinc oxide, thereby preventing iron to get exposed to air and moisture. Okay, last is chrome plating. So here again, you basically coat the iron with chromium in order to prevent air and water to come in contact with the iron, and thus the corrosion is prevented. Now next we are going to study about rancidity. So whenever the fats and oils present in your food get oxidized, then your food starts smelling very bad and it doesn't taste well, and that condition is called rancidity, and you can say that the food has become rancid. So oxidized food having unpleasant smell and taste is said to be rancid. Now the question arises, how can we prevent this rancidity? So basically these are some actionable items which we are also doing at our home. We are keeping our food in refrigerator, we are also keeping our food in airtight containers. So let us understand these one by one. So first is adding antioxidants. So these antioxidants are actually the reducing agent. Thus, the fats and oils present in the food does not get oxidized. So these are the examples of antioxidants present. One is butylated hydroxyanisole and butylated hydroxyl toluene. Okay. Now next is packing the food items using nitrogen gas. The way I told you when I was explaining the example of chips. So basically what happens is, when you have a packet of Uncle Chips or Lays, so you find that half of the packet is filled with gas and half of the packet is filled with the chips. So that gas is basically nitrogen gas. So what happens is, this nitrogen gas is very unreactive. Okay, thus it does not allow oxygen to cause oxidation of the chips present in the packet. Next is by keeping the food in refrigerator. This is what our moms are actually doing right now. So due to low temperature inside the refrigerator, the oxidation of fats and oil in it is slowed down. Now next is by keeping the food in airtight container. So due to reduced exposure to oxygen, the fats and oils present in the food does not get oxidized and hence rancidity is retarded. Now the last thing, by storing the food away from light. So due to the absence of light, the oxidation of fats and oils present in the food is slowed down and hence the rancidity is retarded. Now we are covered with this topic, corrosion and rancidity, and the good news for you, this was the very last topic of this chapter. So you are completed with this chapter. Congratulations for completing this chapter, chemical reactions and equations. So now let us go for the takeaway point. So what is corrosion? It is basically gradual eating of metal by the action of air, moisture or any other chemical substance present in the atmosphere. whereas the aerial oxidation of fats and oils present in the food, making the food unpleasant in taste and smell, is rancidity. So, since we are complete with the summary part, now is the time for Think and Write. Take a pause here and in your own language, try to write the answers to these questions. Okay, now let us discuss these questions. Question number 1. Oil and fat containing food items are flushed with nitrogen. Why? So we have already discussed this. This is because when packed food is surrounded by unreactive gases like nitrogen, then there is no oxygen to cause its oxidation and hence preventing rancidity. Now you need to tell me what are the other gases which we can use apart from nitrogen in order to prevent rancidity. Now the second question. A metal X acquires a green color coating on its surface on exposure to air. So I told you that when you have copper and this copper is exposed to air for a longer period of time, then it acquires a green color coating. So we can say that it is copper. Okay. So how can this be prevented? So I have already told you about their measures, their painting, greasing, and there's one thing also which is alloy, making alloys, which we will discuss in the chapter metals and non-metals. Now the third question, the smell and taste of food containing fats and oils changes after some time. Why does it happen? So it is all because of rancidity. Name the process, it is rancidity. List 2 ways we can slow it down. So I told you that we can slow it down by using antioxidants, or by packaging the food and oil containing food in nitrogen gas, or by keeping them in refrigerator, or by using airtight containers, and either by storing the food away from light. So we are done with the Think and Write. Now I will be meeting you soon in the next chapter, which would be acid, bases and salt. Till then, bye bye and take care of yourself.